The M1 Abrams burns roughly 10 gallons of fuel for every mile it travels, not per hour, per mile. A single battalion of 58 tanks, moving at combat speed, can consume more fuel in one day than a small city uses in a week. The Pentagon has studied this, criticized it, and debated it for 4 decades. And in that same period, not one M1 Abrams has ever been destroyed by an enemy tank in combat. Not one. That is the central paradox of the most successful ground weapon America has ever built. It is logistically unsustainable by almost every conventional measure, and it has an unbeaten combat record no other tank in history can match. How does a weapon that consumes resources at this rate, grows more expensive every year, and was designed for a war that ended in 1991, still dominate every battlefield it enters in 2026? The answer involves a canceled program, a contractor competition, and a set of choices made in the 1970s that the Army is still living with today. Cold War origins. By the late 1960s, the Soviet Union was fielding the T-64, a tank significantly more advanced than the aging M60 Patton that formed the backbone of American armor. NATO planners modeled scenarios in which Warsaw Pact armor would outnumber Western tanks by ratios of 3 or 4 to 1. The M60 could not compensate for that disadvantage on its own. The United States and West Germany decided to address the problem together. The MBT-70 program, launched in the late 1960s, was a joint effort to build a single advanced tank both armies could field. The concept was strategically sound. The execution was a disaster. Costs ballooned, requirements multiplied, and the two nations disagreed repeatedly on specifications. By 1971, the program was canceled, having produced 2 prototypes and a catalog of lessons in what happens when a design is built by committee across national boundaries. Chrysler Defense and General Motors submitted competing designs in response to a new, more focused requirement. In 1976, the Army selected the Chrysler proposal. The tank was named for General Creighton Abrams, an armor commander from World War II, who later served as Army Chief of Staff. It entered service in 1980, built around a single clear priority: find, engage, and destroy Soviet armor at long range before Soviet armor could do the same. Design and firepower. The Abrams made 2 foundational design choices that defined everything else. The first was the engine. Rather than a conventional diesel power plant, the Army chose a Lycoming AEG T1500 gas turbine, derived from aircraft technology. It produced 1,500 horsepower and gave the Abrams a power-to-weight ratio no contemporary tank could match. A 60-ton vehicle could accelerate faster than many cars of the era, sustain high speeds across broken terrain, and run quieter at idle than a diesel. The fuel consumption was known from day one. The Army decided the mobility advantages were worth it. The second choice was the armor. The Abrams was built around a classified composite system based on British Chobham technology, with layers of steel, ceramic, and other materials engineered to defeat shape-charge warheads and kinetic penetrators. Later variants added depleted uranium mesh, making the frontal arc among the most heavily protected surfaces ever put on a production tank. Soviet T-72s firing standard ammunition at combat ranges could not reliably penetrate the Abrams from the front. The fire control system completed the picture. A thermal imaging sight allowed the crew to detect heat signatures at ranges beyond 2 kilometers, in complete darkness, through smoke, and in poor weather. Soviet tanks of the same era relied on optical sights that needed reasonable visibility. In the engagement model, the Army had designed the Abrams around a night battle on the North German plain, both sides moving fast, visibility minimal. The American crew would see the Soviet crew first. In tank combat, that advantage is almost always decisive. Cost, politics, and controversy. The fuel problem was never solved. During NATO exercises in the 1980s, The logistical tale required to sustain an Abrams-equipped force consistently strained planning assumptions. A single company of 14 tanks could consume tens of thousands of gallons in a day of intensive operations. Forward refueling points became high-priority targets because planners understood that cutting the fuel supply was functionally equivalent to stopping the tanks. The debate over whether a diesel engine should have been chosen instead appeared in defense journals and congressional testimony for decades without resolution. The weight trajectory made things worse. The original M1 entered service at just under 60 tons. The M1 Abrams 2SE PV3, the current variant, weighs approximately 73 tons in combat configuration, heavy enough that a substantial portion of the world's road bridges cannot support it. A C-17 transport aircraft can carry exactly 1 Abrams per flight. Moving an armored battalion by air requires dozens of sorties before the tanks even arrive at a theater. Iraq exposed a different problem. The Abrams was designed for open terrain and long-range engagements against other armored vehicles, and it performed exactly as designed in 1991. But the wars after 2003 were fought in cities, where the tank's long-range thermal sight provided no advantage and the threats came from below and from the sides. Improvised explosive devices and explosively formed penetrators destroyed several Abrams that had survived direct hits from rocket-propelled grenades. The Army responded with bolt-on armor packages, each of which added weight without fully addressing the mismatch between a tank designed for European maneuver warfare and the urban counterinsurgency it was actually fighting. The cost per vehicle climbed from roughly $2 million at initial production to approximately $10 million for the current variant. The upgrade contracts flowed consistently to General Dynamics Land Systems in Lima, Ohio. A plant Congress has repeatedly funded above Army requests, because closing it was considered politically and industrially unacceptable, regardless of how many tanks the Army said it needed. Legacy and the future. The combat record of the Abrams, measured against the threat it was designed to defeat, is effectively without blemish. In Operation Desert Storm in 1991, M1A1 tanks engaged Iraqi armor in engagements that are still studied in war colleges. At the Battle of 73 Easting, a force of American M1A1s and Bradleys destroyed a much larger Iraqi armored formation in under an hour, with no M1 lost to enemy fire. The thermal sights let American crews engage at ranges where the Iraqis could not yet see their attackers. The composite armor defeated everything the Iraqi tanks fired. Ukraine, beginning in 2023, provided a more complicated picture. Several Abrams were disabled or destroyed, primarily by drone-delivered munitions targeting the tank's top armor and by anti-tank guided missiles, rather than by Russian tank fire. The pattern was consistent across the broader conflict. Cheap unmanned systems delivering top attack munitions could threaten any heavily armored vehicle, no matter how strong its frontal protection. The Abrams' crew survivability held. Its direct fire reputation was not seriously challenged, but the vulnerability from above raised questions about how any conventional main battle tank would perform on a future battlefield saturated with autonomous strike systems. The Army's next armored vehicle program envisions something lighter and designed from the outset for that threat environment. Whether it actually replaces the Abrams on schedule, given the history of the MBT-70 and every American armored vehicle program since, is a question the record does not answer with confidence. The Abrams remains in production. It is a tank that solved the problem it was built to solve more completely than anyone had reason to expect, created problems that were never fully resolved, and outlasted every program designed to replace it. Thanks for watching. The Abrams is one of those systems where an honest accounting of its failures makes its combat record more impressive, not less. If you found this useful, subscribe and stay with us. Next time, we are looking at a naval program that was supposed to redefine surface warfare for the 21st century, entered service in numbers so small it could barely constitute a fleet, and carries guns for which the Navy decided the ammunition was too expensive to produce. The Zumwalt destroyer is, in many ways, the Abrams story told at sea with a less encouraging ending. See you then.